Okay, we're going to do our first example of a hypothesis test. So here's the situation. Boys, the problem gives us that boys of a certain age have a mean weight of 85 pounds. So this is known information. And then apparently there is a municipal home for boys where there's a complaint about the nutrition of the boys there. So somebody takes a sample. We've got n equals 25 for our sample size. So 25 boys are sampled, and we find a sample mean weight of little x bar is 80.94 pounds. We're also told to assume the population is normal, that is, that boys' weights are distributed normally, and that the population standard deviation is known to be 11.6 pounds. So we're going to test if this claim of malnutrition at the municipal home for boys is something we should investigate, if this is a reasonable claim, to a 5% level of significance. In other words, the question we're asking is it the case that there's nothing different about these boys at this home? There's no problem with their nutrition. We just happen to get a sample that was significantly or somewhat significantly lower than the typical average. Or is this sample so extremely low that we should be suspicious that there is some effect that this home is having, whether it be food or treatment or whatever? And we're going to test this to a 5% level of significance. Okay, so our first job, let's just note that 5%, that tells me that alpha is 0.05. I need to decide my null and alternative hypothesis. So remember, these are statements about, in this case, the mean of the population. The null hypothesis is that the status quo is true. In other words, that this municipal home is not causing there to be some problem in the weights, and that the weight for boys in this home is exactly the average weight for the boy. The mean weight for boys in this home is the same as that would be anywhere else. Our alternative hypothesis is that this is not true, and that we suspect the boys, maybe they're being underfed or something. And so we suspect that their mean weight is below the typical average. So that's our null hypothesis and our alternative hypothesis. Okay, so we are in the situation where we have a normal population. So our sample size is below 30, but we have a normal population, so that's fine. And we know the standard deviation of the population, so our test statistic is going to be a z-score. So z is going to be equal to x bar minus the mean divided by sigma over the square root of n. Okay, so in this case, x bar is our sample mean, which we're told is 80.94 pounds, minus the mean. Remember, we are assuming through this whole test that h naught is true, right? So that's what you always do with the null hypothesis. For the purposes of the test, you assume it's true until the conclusion at the end, and then depending on the conclusion, you may or may not reject it. But for now, we're assuming that it's the case that these boys are that the mean of boys this age is 85 pounds, so we subtract 85 here. Divide by the standard deviation of the population, that was 11.6. Divided by the square root of our sample size, which was 25. When I computed this earlier to get a z-score of negative 1.75. Okay. So next, we're going to compute our p-value. Right? In this case, we're asking, what is the probability of getting a z-score less than negative 1.75? Right? In other words, we're saying if it's true that the mean of boys at this municipal home for boys is the same as anywhere else, it's 85 pounds, then getting a sample of 80.94 pounds or less is a rare sample, right? It's hard to choose 25 boys that happen to be on the light side. So this is saying, well, how rare is it? right? Is it so rare that we're willing to claim that there must be something going on at this home? Or is it just slightly rare so that maybe we'd say, well, we might have just gotten a random sample that happened to be a little bit small? So we go to our Z table. I'll leave that up to you. You can use a calculator or a Z table, and we find a probability of having a Z-score of negative 1.75 or below to be 0.0401. Okay. Notice then 0.0401 is less than 0.05. That is, our p-value is less than alpha. Alpha was our cutoff point. We said if things are rarer, have less probability than alpha, we'll consider them so rare that we suspect they weren't just a random occurrence and that there's something going on, that there's some effect that this municipal home for boys is having on the mean weight of boys. In other words, because the p-value is less than alpha, we reject H naught at a 5% level of significance. Right? We don't think it's true that the boys here have the same average as they would anywhere else. And that's your hypothesis test.